My name is Rouan. I'm a software engineer at a company called Tez. I'll tell you a little bit more about what we do, and I'll tell you a little bit about microservices, specifically JavaScript microservices. And my hope is for me to not give you a theoretical background of how microservices work, because you've probably heard that already, but to give you some sort of idea of, I don't know, some of the things that we bump into every day, and what it's really like. And I'm open to lots of questions as we go if you're keen. So, Tez started as the Times educational supplement back in 1910 or 1914, something like that. And it was basically an insert in a newspaper in London which helped teachers with various bits of news about teaching, perhaps some resources about how to be a better teacher. Eventually it became its own separate newspaper, which they sold for a penny. And nowadays it's a website with millions of users. So teachers come to this website to look for teaching. Think of it as Stack Overflow for teachers. I mean, basically you're going to come there and you're going to find lesson plans that other teachers have shared that you're going to use in your classroom. You're going to go there for news about teaching. And in the same way that Stack Overflow makes money, Tez makes a lot of money by being a place where teachers come. So we sell jobs, which basically means that schools pay Tez to advertise jobs on this platform. Anyways, so there are loads and loads of little bits and pieces that make up Tez.com, and I'm going to tell you a little bit more about the kind of insides of how that might work. So we're at a JavaScript conference, so I'm going to start by talking about JavaScript. Now, Harold, you and I should hang out because we like the same bits of ES6. You stole my slide, basically. Right. So, I mean, there are some of my favorite ES6 bits over here. So, yeah, that same destructuring you saw on Harold's slide. Notice on that last example there that you don't even see a return statement. That's another nice thing about ES6. You can write some really neat small functions, which is great for kind of composability. But the main point here is actually I want to talk a little bit about how we use ES6 or ES 2017. And an important distinction that you have to keep in mind between the server-side and the client-side code that you're writing. So I don't think there's any bones about the fact that writing ES6 is really great. I mean, I was a little bit apprehensive when I started working at Tez because I hadn't really written any ES6 before. I'd just written plain JavaScript. And it was actually surprisingly easy to learn. It didn't take very long at all. And if you want to practice, just take a little plain JavaScript file, convert it to ES6. It'll take you just a few minutes and you'll get a really good idea of how it all works and puts together. The main thing that you have to keep in mind is that we run a full stack JavaScript stack. So what that means is that we use JavaScript for the client, predominantly React, and we also use JavaScript on the server side, normally kind of Express-y type apps. And what that means is that you just have to keep in mind that in order to write this really nice same ES6 everywhere, you need to keep in mind that you've got that distinction between the server and the client. So on the server side, Node, depending on which version you're using, supports very, very good, all the language bits that you need, and you don't have to worry about anything. So don't be afraid of using the latest features when you're writing your server-side code, even if transpilation is tricky for whatever reason in your stack. But when it comes to getting things working on the client side, just make sure you use something like Babel to get your code converted. So we've got a lot of people writing a lot of ES6 across a lot of different services. How do we try and keep some sort of order and some sort of consistency going between the dozens of services that we have? So, I mean, who is appalled by that comma at the bottom there? Hey, are you just like really grossed out? Because the first time I saw that, I really was too. I mean, it's not there. If that was a JSON file, it would be broken. And honestly, it just made me angry. If you work at Tez, you'll see those everywhere. And that's because we use something called ESLint, which you've probably heard of. Basically what ESLint does is it reads all your JavaScript files as you code in them, and it tells you whether you're doing a decent job according to some set of rules. Now at Tez we've been lazy, we haven't written our own rules. We use the Airbnb ESLint config. And the guys at the people at Airbnb are very strict and anal about their JavaScript. And they have very specific rules. One of which is that you have to have that bloody comma at the bottom when you've got a list like that. And actually, like I said, at first I was completely appalled. Then after a while, I realized two things. One is that is actually a very sensible rule and makes your coding experience much easier. Because what happens when audit needs to move to the top because you decide it makes more sense? All you have to do is use your editor to move the line up, and you don't have to worry about moving bloody commas around all the time, which I've spent a lot of time doing in my life. In addition, if you want to add a new line, it's the same deal, right? It's just so much simpler. You don't have to worry about what happens with these commas. If I delete that line, I don't have to worry about deleting the comma above it. So that's the first thing I learned. This particular rule actually makes a lot of sense, and most of the Airbnb rules make a lot of sense. The second thing is that rules are really, really important in JavaScript because it's so possible to code so very differently in one language. And I don't know if you've seen this, but I mean, if someone on that side of the room and someone on that side of the room sat next to each other and looked at each other's JavaScript code bases, they're going to look very different. And that's fine because you work at different places. But when you work at the same place like Tez, and I need to work on one microservice today and move to working on a different microservice next week, I'm going to be really annoyed if it looks very different. And of course, and we'll talk about this in a little bit, things are never going to be exactly the same. But having a base for how you want your code to look is really, really helpful. How we make sure we keep that order is through Git hooks. So we use a tool called Husky, just an NPM library. And basically what we do is a lot of our package.json files include this in the script section. So when you commit code, you're linting. So you're not making a commit that the people at Airbnb wouldn't approve of. And that's really helpful because it means that your code is always nice and consistent across teams. And then before you push, we run the tests, so you're not pushing any code that doesn't pass the tests. And I'm not going to get a chance to talk about this today, but I've got a link at the end. There's also a vulnerability check that we do before we push code using Node Security Project, which basically means that I'm not pushing any code that introduces a library with a known vulnerability. That's just a little security check. So something that you need to know about people who work at Tez. They are like magpies. Does anybody know what a magpie is? I don't really. All I know about magpies is that they are very, very attracted to shiny things. So there is not a new library in JavaScript that someone will not try and use somewhere at Tez. So if there is something new, it will be somewhere at Tez. And it's kind of an interesting thing to deal with. Another thing is that, I don't know if you're familiar with JavaScript, in the package.json file, you've got these little funny carrots, right? And basically what that means is unless someone explicitly says when they publish their package that they're not breaking anything, you trust them and you take that change. And this is a bit of a double-edged sword. On the one hand, it means it's very nice you're always up to date. On the other hand, it means that you can get a bug. Now, when you're using packages like React and Redux, you're probably fine. Those are very robust communities. They're not releasing rubbish changes or bugs very often. But, I mean, we all use different packages from all over the place, and sometimes people do make mistakes. And so you do sometimes have funny things happening. And I've been caught a few times spending a day chasing a bug that was introduced because of a minor or a patch version bump. So the way that we found very helpful to deal with this is one, switching to Yarn so that you have a lock file so that you can know exactly what's going on. And what we do is when we're installing things locally, you just use Yarn. And then when we actually build a service on our Docker container, we use the what's called pure lock file option for Yarn. So it basically means that whatever you're building, you're using exactly what the lock file says. So that's one thing that's been really helpful. Another thing was even on NPM, we used to be really explicit in our build output. So if something was building on Jenkins, we would print out the list of dependencies that were being used for that build. So if something really weird happened between build X and build X+1, we could actually go and see what the difference was. That was kind of one useful thing that we learned. Okay, so I've spoken about the magpies and how all over Tez, they're all over across so many services, we're all trying to add all kinds of new things all the time. And we're really attracted to shiny new things. What this means is that consistency becomes very difficult because you've got someone over there who's just loving the Redux, and already someone's moved on to using Redux Saga over here. And kind of how do you keep that consistency? So the one thing that we do have is we have something called a service template. And the tool we use for this is called Bosco. We'll talk about Bosco a little bit more later. But essentially what this does is that I can say, I want a new service, please. And then it creates a service based on this template that we've created. That template will have some kind of basic building blocks of what a service at Tez looks like. So that's all good and well. The problem is time. So over time, I create my service using the service template today. 3 weeks from now, the service template no longer uses NPM, it uses Yarn because the Magpies have zoned in on Yarn. And what that means is that the service that was created a week ago is now kind of outdated to some extent. And that's just kind of something that you have to live with. And I call it the beauty of inevitable diversity. So in the world, we have a lot of diversity, and I think, unfortunately, lots of people haven't quite cottoned onto this yet. But diversity is a really positive and really good thing. And I think it can be a really good thing in the tech space as well. So I mean, at Tez, for example, we have services that use just handlebars, and services that are much newer, which will use React and Redux and Redux Saga. And it's kind of a spectrum over time. We've got lots of services that build their front end using tools like Browserify and use Gulp, and loads of our new services use Webpack now. For a very long time we used NPM, then we switched to using Yarn, and now NPM 5 supports lock files too. So it wouldn't surprise me if in a couple of months' time we're back on NPM again. What it means is that when I move from service to service, I'm going to have different experiences. And now, there are 2 times I might move from service to service. One is that as much as a website, you can imagine Tez having lots of different areas, as much as you're going to be working in one section of the site as part of your kind of day-to-day work and in your team, you're very much going to be branching out and touching other parts of the system here and there are different kind of shared services that we use. For example, if I want to send an email, there's an email sending service for that. And another thing is that I might switch teams, right? I might go work on a different part of Tez, and I'm going to see a very different kind of thing. One thing that I've learned is that you cannot expect to be less diverse than the technology that you're working with. And it's not just people at Tez who are Magpies. JavaScript developers are Magpies, right? There is a new library every bloody week that does something very similar but not quite the same as something else. I mean, I don't think I've seen another language where so many of the packages start with saying, we're not like X library, we do things differently. And so there's going to be a lot of diversity that we have to cope with. And what I've also learned is that it's a really good thing to just relax a little bit, be open to learning new things. So when you go to somewhere new, you haven't used sagas before, but there they are. You know, be open to learning about how they work. And secondly, be willing to let things go. You know, if you're the sagas guy, and you're really into sagas and you have to work on a service that doesn't have sagas, don't rewrite the whole code base to introduce sagas. Just be cool and go with whatever's happening over there. And I think actually, in terms of being a developer, the important thing is not whether you know how to use Redux Saga or whether you're a handlebars person or a React person. The important thing about being a developer is, can you be cool and can you learn new things? To give you an idea of some more of the diversity that we have at Tez, those are the data technologies that I know we use. There are probably more. I mean, I've been at Tez for about a year and a half. I've used Mongo, Elastic, and Redshift. I haven't touched the other ones. I know that they're around though. And they're actually quite, I mean, Redis, for example, is quite key to our business. Anyways. Another thing that I think is really helpful to try to do when you're working in microservices with lots of people and lots of services is try as much as possible to give people things for free. So the service template is a nice way of kind of getting up and running, but what we found very useful is offering wrappers for common libraries. So if there is a thing that most people at your organization are going to need to be able to do, help them do that with a common bit of tooling. So at Tez we use a tool called Electrician. It's a dependency wiring thing. It's open source. You can go have a look if you're interested. But basically, if you're using Express at Tez, you're not using Express. You're using a thing called Electric Express, which basically wraps Express and offers little bits and pieces of extra goodies. So for example, you'll have some common basic error handling across all services at Tez because of this. So if something goes, well, all the ones that use Express, which is pretty much all of them. If something goes horribly, horribly wrong and your application fails to deal with an error, it will be dealt with because you've got that pulled in. We also have Electric MongoDB, so everyone's using kind of a similar version of the Mongo driver. Electric Rascal for talking to Rascal, which is a RabbitMQ wrapper. And then we also have a bunch of modules that people pull in for things like logger. So TSL logger is a good one example. Basically what the logger does is it's a thin wrapper around Winston, which is quite a common JavaScript logging library, but it does some extra stuff that's specific to Tez that makes sure that it works in our stack. And you never have to worry about that because you're going to create a new service, there's going to be a logging library there, you're going to go logger.log like you normally would, but it's going to just take care of a little bit of magic. It also means that if I need to introduce something new or helpful to everyone else at Tez, I can just go and hack on one of those libraries and it will get spread across nicely. Something else that I've learned is that ignorance is bliss. So I said this wasn't going to be a very theoretical talk, so I'm going to try and speak from my experience, but I have given theoretical talks on microservices before, and one of the benefits you're supposed to be able to have for microservices is being able to really focus on one thing when you're working. And it's one thing that I found to be very true. Tez is quite a complicated architecture, and it's an ecosystem where a lot goes on. But day one, you can join and start working on the service that you're busy working on. I'm not saying that there's not a lot of stuff to learn, but I guess that the key thing is that to get a job done, you have to normally just focus on one little bit. It's not like having a big monolith where you have to know a lot of stuff around you in order to get a change into production. You can kind of focus on what you're doing. Another thing that I think is important is that microservices are more complicated when you have to step outside of that boundary. So once you're not just working on the one or two services that you're familiar with, the interactions between services tend to be quite complex. Definitely more so than they would be in a monolith, right? It's all just sitting in one process. So it is more complicated, but I think something that's really important is that it's very, very obvious to you when you're stepping across that line. So I'm in my box, and I can very clearly see that I'm stepping over into another box, and I don't know exactly what's in between or what this box is doing. So you're very conscious of the fact that it's happening. Whereas if you're working in a monolith code base, essentially what that means is that you're kind of just drifting along, and you might not actually realize that things have gotten more complicated and that the ground has shifted underneath your feet. Okay, any questions at this point? Cool, carry on. Let's talk about Bosco. So, we have a lot of shared tooling at Tez. A lot of it is open source. And one of them is called Bosco. It's the first name of B.A. Baracus in the A team. And essentially what this does is this helps us run things locally. So like I said, and we'll talk about this a little bit later, the architecture of things at Tez, it's not super simple. So Bosco kind of helps you navigate that. So you've got a lot of microservices, and you need to run an app and do something. So let's say, for example, that you want to... what's a good example? Let's say that when someone logs into Tez, you want to display a message that says, "Hello, Susie." And what you want to do is you want to add that to a microservice somewhere, right? And so I think we've got something called app homepage, which runs the homepage. And that's great, but where do I start? Because you actually want to see this thing working locally before you just try and push it to production. So what you're going to do is you're going to join a team. So it's kind of like a GitHub team is what backs the Bosco teams. And what that does is you're going to say, cool, I'm going to be part of the team that does things with the homepage, and there's probably going to be a list of teams somewhere that you can join. And then you're going to say Bosco morning. And what that's going to do is it's going to go and pull a whole bunch of stuff from Tez's servers that you need, but only the stuff that you need for that specific team. So it's going to go get the homepage app, which is going to be a microservice. It's probably going to go get the authentication service, because you're going to need to be logged in order to see that message. It's going to go and it's going to pull the code for maybe the assets, because you're going to need to see all the fancy CSS and stuff, and maybe a few other bits and pieces. So it's going to go and clone those repos for you, do an npm install across those repos, and if you don't have anything specific to do with a dependency of one of those repos, what it's going to do is it's going to go and pull a Docker image for one of those repos, and it's basically going to run all of these services locally for you. So if you have the code on your computer, it's going to run it as a node process using a thing called PM2. It's just basically a little wrapper for running like node server. And if it's not something that you're going to have to touch the code for, we're going to pull down a Docker image. We're also going to pull down a Docker image for infrastructure that you might need. So if your service talks to Mongo, for example, to go pull the name Susie out of the database, it's going to pull a local Docker container down for you for Mongo. And you can have all of these things running locally. And you're just going to get them by saying Bosco run, and it's going to pull all that stack up for you. And the nice thing is that it only pulls the portion of the Tez stack up for you that you specifically need to work in. So if you're just going to say hello Susie on the home page, you're not going to have to care about, for example, the whole stack that manages how people apply for jobs through Tez, or the whole stack that manages how people create and sell and share resources across Tez. You only get to focus on the one little bit that you care about, and that's a really powerful thing. Bosco is not a perfect tool, but it really helps us kind of bootstrap ourselves when we need to work on new things. Is that kind of, do you have any questions about Bosco? I'll share a link to the code afterwards. All right, so the next thing here is about putting things together with Composure. So Composure is another open source library that we have at Tez, and I'll share the link for that as well. But have a look at this page up here. We have some sort of navigation at the top of the page. And then for this particular page that you're looking at here, this is for a school, in this place, this test school over here, to be able to see who has applied for a specific job. So what you can see at the top there is some navigation for the specific school. So there's a general Tez navigation at the top. You can switch from resources to jobs to the community to the news. There is some sort of shared navigation for this kind of like jobsy section where you can switch between jobs, managing the site that people see when they're trying to apply for jobs, statistics that you might be able to see about your jobs. And then at the bottom here, you can actually see the page that you're on, which is showing you applications for this job called test pending, and you can see some people down there have applied for this job. The trick is, this is a microservice run website. And so all of these bits of information, all of these bits of HTML are coming from different places. And I don't know about if anyone else has ever had this experience, but before I joined Tez, this just blew my mind. I had no idea how this worked. I had no idea how you could have a set of dozens of different microservices coming together to put one HTML page together that a user sees. And so I'm going to try and explain to you a little bit about how that works. And essentially it's this tool that we have called Composure that does a lot of the magic for us. And essentially what it does is it does routing and composition. So on this example over here, that very top bit, the thing that gives that to us is a service called Service Site Assets. And basically it deals with a lot of assets across the site. So there's this thing at the top there which we call the masthead. And it's basically the navigation. Any page you visit on Tez.com is going to have that strip across the top. The bit that's going to give you the middle over there is going to be this kind of jobs portal that I was mentioning. And then there's an application-specific service for job applications that's going to, for tracking job applications, that's going to give you that big bulky bit at the bottom there. And the trick is kind of like, how do we put that together? Well, Composure sits between every request, or lots of requests, between a user's browser and Tez's services. So what happens is that it intercepts that request, and it basically goes and asks all the different services for the bits and pieces that it needs and puts them together. So an HTML page might look something like this. So putting things together with Composure. And then that's exactly what it's doing, right? So you can see that there's a CX URL, and it's saying that from the site asset service I want the masthead, and then it's saying from some other widget, please go and get me something else. And so what it's doing is it's getting the request. In this particular example over here, let me walk you through this. I've got pictures. Okay, let's say we wanted a really simple page that on Tez.com is going to show us a smiley face. Right, so the full stack that it goes through is first it's going to go through Fastly, which is a cache and CDN. Don't worry about that too much. It's going to go via Nginx, which does our routing. And Nginx is going to know whether something is going to care about going to Tez Composer or not. So if it goes to Composure, it's then going to go to the Smiley app, which is going to say, hey, what I need is some HTML, which has the nav, and then also has my smiley face. And then Composure is going to go, no, okay, cool, I know where the nav lives. It's going to ask for that bit from the asset service, and then it's going to give the whole bunch put together back into the browser. Make sense? Cool, okay. And just so that you know, if you are doing an ajax request, it just goes to Nginx into the Smiley app. It doesn't go through the whole spiel. Okay, so something else that I want to talk about, which I think is really important, is how the services talk to each other and how they work together. So, how many of you have ever been in a shop and needed something? Like, let's say you're in a big supermarket and you're looking for the candles, right? So you're going to go to ask someone, you're going to ask them, hey, where are the candles? And they're going to tell you, right? And that's kind of what talking to each other over HTTP is like, right? It's a synchronous kind of once-off, I ask you. How many of you have been in the supermarket and the person you asked did not know where the candles were and then shouted across the warehouse to someone else, where are the candles? And then that person shouted at someone else saying, where are the candles? Until eventually some like curmudgeonly person comes out the back who like knows where all the things are and shows you to the candles. The thing with HTTP is that it's the simplest form of communication and we use it for lots of things, but the problem is that network calls are expensive, and you can end up in that situation where you're just continually asking people for what you need and you kind of just get stuck and it takes a very long time. So HTTP, in our experience, you should use when you really need fresh data or when the data that you need is very easily cached. Another way that we talk to each other is through RabbitMQ. So this is basically messages on a queue. And how we do that is, this is a simple example, but essentially, if an event happens in jobs, to the thing that keeps track of job adverts, it's going to publish an update to some sort of RabbitMQ exchange, and we're going to listen to it. So let's say, for example, someone publishes a new job advert or changes something about a job advert, and us in the application that deals with applications for jobs needs to know about those changes to the job. We're basically going to grab that message and put it in our database. And we're basically just going to cache a little bit of the data that we care about from another service, locally in our little MongoDB. And then we can just always get it straight out of our MongoDB. Whenever it changes, we pull in the update and we update it, right? And so we kind of cache things ourselves on the data layer, which makes things much faster and much more reliable. If something goes wrong, we'll try a few times and then we'll put it in what's called a dead letter queue, which is essentially saying, oh my goodness, I couldn't deal with this message. Here, human, deal with it, please. And then what will happen is we check to see whether we're actually working together properly. Something pops into that dead letter queue. That sends a metric via a thing called StatsKey to a service called Datadog. I don't know if you've ever heard of Datadog. It's like a monitoring service. It's pretty cool to check out. And then that's going to send an alert to HipChat, which is what we all use to talk to each other at Tez. And then a human is going to go and look in the logs and see, cool, what happened. Okay, right. So I'm going to whip through very quickly a couple of questions that I got asked on Twitter beforehand, and then I'll open it up to you. So someone asked me, who's Peter Lowe? Hello. So you asked me how the services talk to each other. Hopefully I've answered that. How do you handle tracing, logging, service discovery, load balancing, etc.? Okay, so load balancing is Nginx and Page Composer and Fastly, that first kind of section of the stack. Logging, we have a shared kind of logging library. What that does is it pushes messages to Redis, and those get sent through to Elastic. And tracing, every request has a trace ID added as I think an HTTP header. And so you can use that in the logs to see what's going on. And me as logging something, never have to care about that. The logging library that we share takes care of that. Brett asked me about authentication and credential role management. Hello. Cool. Cookies. So because most things happen via HTTP, even between services, we just pass cookies around. And that tells you who's asking you. And if you want to check a specific permission, there's a service that will tell you the answer to that. Just going to ask that for whether this person has permission. Simon asked me whether it's realistic that different microservices are on different stacks. I mean, I haven't tried it, but I think a lot of the stuff that I was talking to you about today wouldn't be possible if we weren't sharing a common language. And so I do think it would be tricky to have different languages. I think basically what you want is you want one language that you do most things in, and then if something really does need to be done in Ruby, or really does need to be done in Java, that doesn't seem right, then you can have a service that works specifically in that. Cool, do I have any other questions? I've got some helpful links. I'll tweet my slides out afterwards, so you can go and have a look at those. But we've got just 2 minutes for questions while whoever's next sets up. Pretty well. As much as people at Tez are magpies, they can be pretty anal about being kind of pedantic about making sure that those sorts of things are done right. Yeah, I mean, I think if it's a breaking change, the version will definitely change. People are pretty disciplined about that. No, not normally. I mean, so generally, if something has to change across the organization, there's normally a good reason for it. So if, for example, you change the Mongo library to use a new version of Mongo because we've changed the version of Mongo we're using, you're going to have to talk to everyone to change that anyways. And so generally, if it's a big change, it's because it actually is a big change and warrants whatever kind of big changing everyone has to do. Yeah. Completely. So in this particular stack, you could have whatever front-end bit on your particular page that you want. The reason we try not to do that is because we want to keep like a level skill set between people. And so if we have like one Angular service in a place where we all use React, like it's unlikely to be worth the hassle it's going to cause. Cool. I'm out of time. So thank you very much. It's a break now though. And so I'll stand right here and you guys can come and ask me questions. Thanks.